Hi everyone and welcome back to our series Build a Large Language Model from Scratch. In previous one we discussed about how can we create a simple tokenizer using Python. Now in this tutorial we discuss about the byte pair encoding and data sampling with a sliding window. So let us start our tutorial right now. So Tamaru, after 18 years later on, RCB just lifting their first IPL trophy. Especially talking about the jersey number 18, obviously our Virat Kohli. See how much dedication and how much loyalty he have actually. He give all of the things, he gave all of the effort, all of the skill in this team, and finally he got the reward. Same thing in our case. If you have the Go dedications, if you have Go dedication in the coding, programming as well as completing the series, you can do it. Just believe yourself, and it's God plan, right? Now in this tutorial we discuss about the byte pair encoding. So what is the byte pair encoding actually? Byte pair encoding is one kind of tokenization algorithms that is specially in terms of the large language model. It's called byte pair encoding. It is especially used by the GPT-2 or GPT-3, even the chat GPT. Okay. So it's nothing but one sub-word based tokenization algorithm. Sub-word based tokenization algorithm. Just take the pen and paper and note it out. Okay, tokenization algorithm. Also, if you are a RCB fan, just comment with your RCB, or you can say the A sala kam nambe. Okay, you can do it in the comment box. Okay, I got so amount of low comment in the comment box, so it's better you can do a comment. So it give me some kind of inspirations to making this kind of projects. I mean, this kind of tutorial. Now, so what is actually subword based tokenization? So before discussing about the subword based tokenizations, we will be discussing about the tokenization algorithm and its type. So there are three types of tokenization algorithm is available. So tokenization, थोड़ा मैं स्पीड लिख रहा हूँ, algorithm. So there are basically three types of tokenization algorithm are available. First one is called the word based tokenization, word based. Second one is called the subword based. And third one is called the character based. Okay, see, character based. So tokenization algorithm, it has three types: word based, subword based, and the character based. Now let's see what is actually word based tokenization algorithm. So word based tokenization algorithm is already implemented. I mean, we already implement it. Tutorial number 2. You can go and check out. Let's say I have one sentence. Let's say build an LLM. Okay, let's say from scratch. Scratch. Okay, may okay, but so build an LLM from scratch. So what it will do, it will try to converting all of the word as a token. I mean, it is considering the all of the word as a token. So build is a token. So let's say build is an separate token, and is a separate token. LLM is a separate token. From is a separate token. Same thing for the scratch is also a separate token. I mean it's considering every word as a separate token that you already implement in the simple tokenizers. Now, what the problem is actually happening in case of word based, or why GPT actually using here the sub word based tokenization algorithms. So in tutorial number 2, we see that we having some problem in case of word based tokenization. That's called the out of vocabulary problem. Okay, out of vocabulary problem. That's the actually main important or the most important problem in case of the actually the word based tokenizations. So out of vocabulary, that's mean, let's say I having a sentence which one is not available in my vocabulary, so it will give me some kind of out of vocabulary problems. So after removing that, we're actually using here some kind of spatial tokens, or you can say the context token, like unknown token for handling here the unknown word. And also you're going to using here the ant of text. Okay, ant of text in order to handling here when the page is ended and when the new page is started. Also BOP and SOP, we actually using here those kind of tokenization algorithms. I mean, the context based tokens. Okay, so those are the problem in the case of the word based tokenizations. Now what is this character based tokenization algorithm actually? So in case of character based, you can see the name is suggest like character. So let's say I have one word. Let's say I am Sugot. Okay, I am so good. Okay, this is nothing but one kind of sentence. So in case of character base, what it actually do, it will making this I as a similar character, A as a similar character, I mean different character, and M is a different, not character, actually different types of tokenization tokens, and same thing for S and same thing for the O. Okay, so what actually happening here, see, it will converting each of the character as the tokens. So in case of the character based tokenization, it will reduce the out of vocabulary problem, because in case of the English word, so in case of the English word, we know that we just have the 256 character. Okay, I mean I'm talking about also the special character available. It total number of characters is not about 256. That's mean our vocabulary size is 256, and all of the word is coming. It's obviously lies between these 256. That's mean our out of vocabulary problem is resolved. Okay, out of vocabulary problem is also resolved. Same thing in case of word based tokenization, we having also one problem, that similarity is not captured. See, similarity is not captured. Similarity is not captured by. Now what why actually talking about like that, similarity is not captured? Let's say I have one word called, let's say, boy, and another word is called the boys. So the word-based tokenization is actually making these two word as a different token. See, two word as a different token. But in case of boy and boys, it having a root word called boys. It's nothing but on root y, because the meaning of the word is similar. So why should you give here any kind of why should you actually give here some kind of special character ID? I mean some token ID. Okay, that's when the similarity is not captured. In case of the word base, those two word is not similar. Those two word is not similar because it have some different types of token ID. That is also the main problem in case of the word based tokenization. So what actually happening in case of the character base, so it resolve the out of vocabulary problem, but the problem is the sequence length. The sequence length is quite length. Okay, it's quite length because how you need to tokenize the each of the sentence, obviously it will taking the more of the token ID. Okay, let's say I have one sentence called I'm a good boy. So if I'm going to convert them into character based tokenization, so see, I am, okay, 1 2 3, see, 1 2 3 4 5 6 7 8 9. It will have the 9 token just for the three words. That's mean the sequence of the token is increased. Okay, sequence. Okay, you can say the length of the sequence is also increased. Also you can say tokenized sequence is much longer than the initial raw text. Obviously that's also one problem. That's still taking the enough time for the processing, and our training is also slow. Also one more thing, that semantic meaning is not captured. Semantic meaning is not captured. Semantic meaning is not captured. Okay, because see, if I see the word meaning is not captured, it have just have some separate kind of tokens. So that's the basic problem in case of the word based tokenizations. Same thing for the character based tokenizations. So what is the subword based tokenization algorithm actually? So subword based, we know that it's used by our GPT. So in case of subword based tokenizations, so let's say subword based tokenization. So in case of subword based tokenizations, it having two rules that I need to follow actually. So rule number one, say don't split frequently. Okay, don't split frequently used word into smaller subword. Smaller subword. Why it's what it just actually meaning? Don't split the frequently used word into smaller subword. Let's say I have one word called boy. Let's say boys, or you can say that's a token let's say tokens, and let's say tokenizing. Okay, let's say or tokenizing. Say both of the three words have some similar meaning. So in case of the subword based tokenization, it's not splitting the frequently word into the smaller subword. That's mean the root meaning is the same. Root meaning is the same in case of subword. Now let's see the rule number two. Okay, let's say role number two. Let's say role number two. So in case of rule number two, we can say that split. Okay, let's say split the rear word. I mean, which word is not much available in our data sets, which is called the rear word. So split the rear word into smaller meaningful subword. Okay, smaller meaningful subword. Okay, that's mean actually. If I have a word called girl, okay, so girl should not be split. Let's say should not be split because this is the frequent word. So if I have the girls, so it should be split into girl and s. Okay, so that means see our root word is reserve. Okay, root word is reserve. But in case of word base, it will considering this girl and girls are the separate tokens. So that's why this BP is internally using here this sub word based tokenization. Now let's see how can you implementing this byte pair encoding. So implementing the byte pair encoding can be relatively complicated. So you will actually using here an existing Python open source library that's called a tick token. That's called a tick token. So tick token. So what you can do, you can simply go into use your terminal and type here pip install tick token. Julius, it better to install the tors, I mean the pytors, because in next one we discuss about the data sampling. Data sampling with a sliding window. I'm going to teaching you from this book, build a large language model from scratch, that you can see is in front of mine. So just install this library. Now we start writing the code about the tick token using the tick token library in order to implementing here this byte pair encoding. Okay, so what I can do first, you're going to import in here the tick token library that you install by using pip command. So let's go on here and type here import tick token and shift enter, or you can also using here this run button. Now what I can do, we are going to initialize here our encoding methods. We are going to using here the GPT-2. So once you actually install the tick token, so you can initialize the byte pair encoding from the tick token. Okay, so you can using here this GPT-2 as well. So let's say tick token dot get encoding. So get encoding function, and you can give it here the GPT-2. Okay, so let's give it to here as a variable called tokenizers. Tokenizer. So this is our algorithm, BP algorithms. So you can see it also initialize. Now what I can do is simply going to taking here some kind of raw text. So let's say text is equal to, let's say I'm going to give it here a text that I give it to inside of tutorial number 2. Let's say hello, do you like tea? And then you're going to give it here the token. Let's say end of text token, and then we need to also close it, and then you're going to give it here in the sunlight. Okay, let's say terraces. Okay, terraces, and then you get here the another line. So let's say of some unknown place. Okay, let's say place. So what I can do is simply going to convert them into some kind of token ID, or you can say the integers, because before, I mean, after doing the actual tokenizations, it also do the actually convert them into some kind of token ID. So this is called the encode method that we see in the simple tokenizations. So let's say tokenizer. So let's say tokenizer dot encode. So you don't need to actually implementing this code. You just write it the methods. So encode, and inside this encode method, you're going to give it to here the text, and you also give it to here the allowed specials. So you give it to some special type of context token. So in our case, it's nothing but the end of text. Okay, let's say end of text. Okay, let's say end of text. That's mean in case of the byte pair encoding, you can also give it to here some kind of special token as well. So let's make it as the integer, or you can say the token ID. So let's say make it as the integer, integers, and then you can simply go to printing these integers as well. I mean the token ID. So let's try to printing the integers. Okay, integers. Here you go. So you can shift enter. Now you can see you got some kind of token ID that we also get in the simple tokenizer as well that we implemented in the tutorial number 2. Just using the encode methods. Now we can simply going to using this decode method in order to decoding this out. So you can using this tokenizer. Okay, see how cool is it? Tokenizers and dot. You can using here the decode method. Okay, and then you can pass it to here the integers that we get it from here. I mean get back to the text. So this is the string. Okay, that's the string. And now we can simply kind of printing this out. Okay, let's printing here the strings. Okay, so let's say strings. Okay, strings. So you can see hello, do you like tea, and of text in the sunlight test of the some unknown place. Okay, that you can see. Okay, so that you can see how can you encode it and how can you decode it. Also it can handling some kind of unknown token as well. Okay, so if the token the hello is not available, obviously it can also handle it out. Okay, that's also one goat case in case of the tick token or the tokenization algorithms. So this is the algorithms that is used by the GPT. Okay. Now we are going to see that what is the data sampling with a sliding window, also called the input and target pair. Also one more thing, why actually give it to here this end of text, because the train model such as gpt-2 and gpt-3 and the original model is used in ChatGPT has a total number of vocabulary size is 50257, and the end of text being assigned the largest token ID. So that's why actually using here the end of text that is also used by the ChatGPT. That's why I give it to here a lower special text. Now you can start our next part about the data sampling with the sliding window. So now let's discuss about the data sampling and the sliding window. Let's say data sampling with a sliding window. With a sliding window. It's look like the D as a sliding window. Okay, approach. So it's also called the input and target pair, because in this one we discuss about the input and target pair in our large language model. Input and target pair. Basically talking about the dataset, that how the dataset actually look like. So what I can do, let's go on the book for the illustration purpose. So you already discussed about what is the byte pair encoding and how it actually work. So in case of byte pair encoding, it actually using here the sub word based tokenizations. So you can see I have some kind of unknown word in the form of text sample. So a k w i r w i e r. So which one is not completely one kind of word. I mean it's one kind of the unknown word. See how the byte pair encoding is actually handling. So it's just making AK as a simple tokens and gives some kind of token ID. Same for W, same for IR, same for W, and the spaces IER. That's mean if you have some kind of unknown word, so it will directly handling it using this byte pair encoding. And also you see that how can you implement the byte pair encoding using the tick token library. That's cool. Now let's see what is the data sampling with the sliding window approach. So we see that data sampling with sliding window approach is also called the target, I mean input and target pair. So see how LLM actually train in several types of data. Okay, I mean how it actually train. So we having one examples. Let's see LLMs learns. You can see the blue one. It's nothing but the input, and learns is nothing but our output. And also you see to predict one word at a time. This is the called the mux. So if you have the knowledge of the transformer, then you can surely know that what is the mux actually. So mux is nothing but which one is not going to seen by our large language models. So how can you give here these LLMs to the large language model, and our large language model predicting the next word called learn. So that's why the large language model is also called the next word prediction based applications. So you can see learns LLMs and is as the input, and learns is nothing but an output. In the next iteration, I mean iteration number 2, this learn is going to in the input sections. See, going to the input section, and right now 2 is the output. And then iteration number 3, you can see 2 is going in the section of input, and predict is right now the output. That's mean this is one kind of auto regressive model. That's mean when the iteration is increases, I mean for every iterations, input what would be the output. Okay, so see learns is going to as the input. Okay, and same predict is going to be the input, and one is nothing but the output. Okay, this is happening in case of the actually large language models. So what actually I'm talking about, let's go on the mirror. Okay, so we see some example that let's say LLM. Okay, let's say learns. Okay, so what we actually do, we just give it here LLMs as the input, and learns is give it as a output. Okay, you can say as a target. That's why it's called the input and output, or you can say input and target pair. So in case of the large language model, so what you can do, just we are going to shift it by one. Okay, just give it to shifted by one, shifted by the one place. So this is how our large language model is dataset look like. So it's also called the auto regressive model. See, it's also called the auto regressive. Let's say auto regressive. Okay, why every time the iterations, I mean of the next iteration, what will be the output. That's what it's called the autoregressive. Also it's called the self-supervised. Okay, it also called the self-supervised. Supervised. Why? Because it's taking the input from the previous tokens or previous lines, and that's why it's called the self-supervised technique. You can also considering this one as an unsupervised technique as well. Okay, because it don't have any supervised kind of data sets. Just like the classification problem, you have the data set with having the features column as well as have the target column, so you don't have any like that. So this is how the data sampling with a sliding window actually work. Sliding window means, see, if you have the knowledge of the DSA, you know what is a sliding window actually. Sliding window is one nothing but one kind of window which one is sliding from the left part to the right part. Okay, this is one kind of approach that is used in case of the large language model as well. Now what I can do is simply going to implementing this technique using the PyTorch library. Okay, so let's implementing that we discussed earlier. So that's our topic about the data sampling with a sliding window. So I can give it here one kind of heading. So let's say data sampling with a sliding window. Let's say with a sliding window like that. Okay. So you can go on here and make it as a markdown. So first what I can do is simply going to loading our data. I mean the verdict short story. So let's say with, and you can using here open, and inside this open we give it to here the verdict story. So let's say verdict dot txt, and then we're simply going to read it. So let's say r, that's the mode, and as well as we need to also give it here the encoding type. So let's say encoding. So let's say encoding is nothing but the UTF-8. Okay, unsigned integer 8, UTF-8. Okay, that's a encoding technique. Okay, then we're simply going to make it as a file as f. Then we're simply going to read it. Let's say f.read, and after that let's make it as a raw text. I mean just give it here one kind of variables, and then after that we're simply going to apply here the tick tokens, or I mean the tokenizer that actually created. You can see, okay, that you can see tokenizers. So I just run it again because I'm recording in the second time, that's why. So let's make it tokenizer that you created dot encode, and you're passing here the raw text. Okay, and before you just give it here some kind of sample text that you can say hello, do you like tea, and a text in the sunlight test, and then we're simply going to give it here one kind of variables. So let's say encoder text, and then after that you can simply going to printing the length of the encoded text. Okay, so let's try to printing this out. Let's say length of the encoded text. Okay, so encoded text. So you can see here we got here 5145 the tokens. I mean the total number of tokens in the training set. So after applying here this byte pair encoding tokenizers. Now let's see the 50 tokens from the dataset for the demonstration purpose. So you can simply go to checking this out. Let's say encoding text, and you're taking the last of the 50. So this is the last 50 of the tokens that you can see. So those are nothing but my samples. So I can create a variable as those. I'm just following here the book because so in the book they actually give it here the variable name as an encoded sample like that, enc underscore samples. So we can easily printing this out after the later on. So you can printing like that. Let's say enc sample. Then you can see our sample tokens is nothing but in a one list. Okay, you can easily visualize them. So now what I can do in the box, they're told that so how can we move the first 50 tokens from the data set for the demonstration purpose. So as a result, the slightly more interesting tab presses in the next step. I mean, they're actually talking in the book. Now after that, what I can do, we simply going to actually creating here the input and the target pair. So for the input and target pair of the next word prediction text is to create two variable x and y. Okay, so let's go on the board again. So it will be better for me. So in case of the input and target pair, so input and let's taking here one pan. So in order to creating here the input and target pair, so you need to taking here two variable. One is called x, another one is called y. Okay, it will be the good choice to give take here this kind of actually the variables. Okay, so it's just considering here x as an input and y is a target like that. So let's say I have 1 2 3 and 4. That's my input target. So my output target is not, I mean the sorry, there's my input. Okay, that's my input pair. So my output pair is look like that 2 3 4 and 5. Okay, that's mean high end my input tensor is 1. I just make it as a tensor later on. So the my output is nothing but the 2. Okay, that's mean high end my input is 1, my output is nothing but the 2. So high end my input is 1 comma 2, my output is 3. That you can see 3 because we're doing the next word predictions in case of the chat GPT or in case of GPT. And then we have 1 comma 2 comma 3 and our output is 4. So how can we give it to the input of the 1 2 3 4 and our output is the 5. So this is how actually this is how the input and target pair look like. So not also implementing this one. So in here input and target pair we have one variable called context, or you can say as a maximum length of the your input and target pairs. So in our case, we just making at the context size as a 4 that you can see, and our target size also similar. Okay, so you're going to implementing this one. Okay, see how you implement it. How and our value is the 1, and our output is the next word or the next tokens or next token ID. I mean number 2. So how and my input is 1 2, my output is nothing but a 3 like that. Okay, so you can easily implementing this out using the context id of the context of the 4. So let's implementing this one. So we have one variable called context size. Let's make it as a 4. Then you need to create here two variable x and y. Okay, so input and the target. So this context size determine how many tokens are included in the input. You can make it as a max length. Now in the x, so x is nothing but the is it's coming from the example. I mean in the enc sample. That's why it's creating here variables. So let's say enc sample underscore sample, and from the sample we're taking the context size. Okay, let's say context size. So in our case, the context size is nothing but the 4. Now what about this y? So it's also taking from this encoder samples, and we just increment it by 1. So taking it from the 1 to the context size plus 1. Simple, simple as it is. Okay, so we simply going to printing this out. So if you know about some basics of Python, I mean how can you do the slicing, so you obviously understand that what is happening on here. So you can simply going to printing this out. Let's say print here, we can say that we can give it a name string. Let's say this is for the x. Okay, here you go, and you can simply going to give it to here x. uh, okay, because we use the f string, so obviously I have to use the curly brackets. Then I'm going to printing here the y. So let's say f, and let's make it as a y, and let's say this is the y. Now you can see high my input value is 43672885 or 1464. My output is 3672885 1464 and the 1807s. Okay, and my context size is nothing but the 4. That's been 43672885 1464. So why should be? It's coming from here, it's starting from here. So if I give it to the context size as the 8, so this is how look like. Okay, this is how look like. Okay, so we just give it here straight as 1. We discuss this later on when you actually creating the data loader, right? Now we can also printing this out. Okay, I mean we can creating here one kind of for loop, so that you see in that the draw skin. I mean look like that, we are going to printing this out using one for loop. Let's try to printing this out. It's better at taking some kind of shell actually. So let's printing this out. Let's say for I in range, we start from the 1 to the context size plus 1. Okay, let's say context size plus 1. Okay, plus 1, because you started from the 1, not from the 0. That's why you know the basis of the array, right? And then we're simply going to take it from the encoded sample, and then we're taking passing here this context size. So in case of context size, because it's itered to all the value from here, so you can directly make it as I instead of give it to the context size. So this is nothing but our x, or you can say the context itself. And then we have our desired output. So we can say that desired, okay, let's say desired is equal to encoded samples, and you can give it to here the I itself. I just give it to the context size, and then you can printing it out. Let's say print. So you can give it to here the context, and then you can give it here some kind of arrow, this, and then you can printing here the desired. Okay, let's say desired. Okay, that's it. You can printing this out. Now you can see how it look like that. You already discussed about that. Okay, so high and your input is 40, your output is 367, and high and your input is 40 and 367, you got the output at the 2885. Same thing that you can see that we discussed in the boat as well. So this part is nothing but the input, and this is target. Okay, that you can see that the code is actually printed. So you can also use it in your uh, i- in your data set as well for the decoding purpose, because you see that we just do the encode one, so you can also decode it, okay, in terms of text. So what you can do, you can copy this out, and just instead of give it to here this context, you can using here the tokenizer. So you can using here this tokenizer dot decode, and you can give it to here the context. Okay, you can give it the context. Same thing here in case of the dessert. So you can using here this tokenizer. So let's say tokenizer dot decode, and we can give it to here the dessert. Okay, because this is a list itself. So now let's run it. So you can see the I. Okay, the context size is nothing but the encoded sample of the I and the I. So we start from 1 and the context size. So that you can see actually. So we print tokenizers. So I, and you can see H is printed. So I H is nothing but the AD, and I hat is it's nothing but coming as a always, and I hat and always is as a thought. Okay. So is there any wrong? So it start from 1, and we say the tokenizer dot decode of the context. So let's checking this out. Is there any error or not? So encoded text, it's tokenizer dot decode of the raw text, and this is the context that actually got sample. Okay, everything is fine. That you can see how you have the I, so we got in here H, and how I have the IH, we got it the AD, and how I have the I hat, and I got the always, and how I have the I hat always, we got the though. Yes, we got the output using here this decode technique. Okay, that's when our code is also working very fine. But in our book, it give me another examples. It when we got the AND, it get the established, and when we taking the input as the AND established, getting as the himself. So that's why I'm quite confused why this output is not matching with the box. Actually, this is not matching just because of we just printing here the 50. So just you need to printing here the last one. So that's why this problem actually it's not printing just like it's available in our book. So now let's start running this out. Now you can see we got the same output as like the book. I mean, because I'm following this book, the built large language model from Scratch by Rashka, Sebastian Rashka. So that's why I'm quite confused. Now you can see we have the input as and so we got the output as established, and in the next iterations, this input, sorry, this output is going to it's going as the input of the next iterations. Okay, you can see established. Same thing for himself. Now himself is going to the input pairs, and we got the output of the ints. Okay, so this is how this data sampling with the sliding window approach actually work. Now we'll implementing a data loader that can fetch the input and output target pair using a sliding undo approach. So for this case, we're going to using here a framework, or you can say the popular library by Facebook called the PyTorch. So make sure you install this library, and otherwise it not work. And I'm using here Python 3.8.5. Also, I have one Python version that is also available. You can see Python 3. The version is nothing but the Python 3.12, but in this version, uh, I don't have the PyTorch installs. So that's why I decided to use the Python 3.8.5 because this is simple code. We are not going to training it yet here. We're just going to creating here an data loader so that we can convert them into the PyTorch tensors. Because in the full tutorial, you're actually using here this framework. That's why. So before implementing the data loader, let's see one kind of examples. So you can see we have one sample text in the heart of. So you can see the blue lines as well as the red line. So the blue line is nothing but my input pair, and this is my target pair. That you can see tensor containing the input and tensor containing the targets. I mean x and y. So here my input is in the heart of, and the output is the heart of the heart of the. Okay, that means it will actually go to the one step more, okay, in the heart of, and it's nothing but the heart of the. So in the next iterations of the chunk, you can considering this as a chunk. So you can see the city stood up. So in the y, you can see city stood the old. That's when when the context size, I mean the max length size it, and then the next word is started. Same thing for the x. Okay, same thing for x. Now what is actually a stride? If you know about the convolution operation, that's mean a stride is nothing but just go to the one block to another block, just having one gap. So same thing you can see in the heart of the city. In the heart of the city, when you have the just start as a one, that's means one moves in input b by the one positions. So you can see this is for the in the heart of the batch number one. In the after batch number two, it's nothing but the heart of the. Okay, so when you have the start of four, so it will move the input field by the four positions. So input field batch number one is nothing but in the heart of, and after four token, it will taking as a next one. Okay, it's taking the next one, next input tokens. Okay, that you can see. So it's important at all in case of that, and you can also see that and establish himself like that. Okay, but in here it's quite different. Okay, because it just printing the next tokens. So in here you need to also training this out. We need to convert them into some pytorch tensors. So as well as we need to also implementing here the data loader. So it's available inside the pytorch library. So now let's creating this out using the data sets and data loader class. So what we can do, we simply going to import here torch first. So let's import here torch. So let's say import torch. So you can just go to the PyTorch website. So let's checking this out first. So you can go to the PyTorch website. So let's say PyTorch. Okay. So this is the official link of the PyTorch. You can go on here. You can get started. This is an amazing framework, uh, just like the TensorFlow. So click on get started. Then you can install it. Make sure you install the stable version. So you select your OS. So you're making this Windows. So you can use the peep, or you can also use the libtors, or you can also use the source. So if which language you are using, if you are using C++ or Java, you can select one from here. And if you're using Python, so you can select it from here. So if you have the CPU, you can easily using the CPU one. And if you have the Coda versions, how can you use the Coda? You can select any of them. So how can you check your Coda version? You can just you open the command prompt, and you can type here NVIDIA SMI. Okay, NVIDIA SMI. Make sure that you have the NVIDIA GPU. So in my case, you can see I just using here MX230, which one is cold wide versions. I am not a rich guy. So my version is nothing but 12.5, my Coda versions. So I can using here this 12.5 or 12.6, or you can also getting some kind of versions. You can search on Google. Okay. So I can just selecting this one. I can easily copy it and I can paste it to our terminal. So it will easily install. Okay, but quite taking time, and it's also heavy as well. Okay, so now what I can do is simply going to import here the pytors, I mean tors, and after that you also import here the data class and data loader. So let's say from tors dot utils, it's inside the util package dot data. We're simply going to import here the data set and the data loader. Okay, if you don't have any knowledge about the pytors, then how can you create the application on that? I already creating 2 or 3 projects using pytors. You can easily get it that first when you actually training any kind of machine learning models or deep learning model. So first you need to actually creating here and data sets of the pytors and also the data loaders. That's a mandatory thing. So same thing we are going to use it here. Now, after that, what I can do is simply going to creating here a class called GPT dataset version number one. So let's say GPT dataset version number one. Okay, let's make it B as a capital. So this is one class which one iterate to the dataset itself. So let's say dataset. So let's take in some shell. It will be better for me. Datasets, and after that is simply going to initialize here. Let's say def init, and here we give it here some kind of parameter. Let's say self, the txt, I mean text itself, and the tokenizers. Okay, I mean our byte pair tokenizers, and then the max length you can consider in this one as the the context length, and the strike that we already discussed. Okay, now after that what I can do is simply going to creating here 2 variables for storing here the input ID and the target ID. So let's say self dot input IDs. So let's say input IDs. So which one is a lead itself? Then you have the self dot the target ID. So let's say target IDs. Okay. Now we are going to using the tokenizers. So let's say tokenizer. First, you need to encode it. I mean, our encode our text that is coming from here. So this is our this is give it here the token ID as a return. So token the IDs. Okay, it should be the product. And after that, what I can do is simply going to iterate to all the value. I mean, iterate to based on the context length that we do in here as well, that you can see. So what I can do is simply going to creating here a for loop. It's a for I in range, and here you give it start from 0. Right now, for this time we start from 0. Then we give it here the length of the token ID, how many tokens we have, and then we minus the max length. See, we minus the max length. Okay, max length. So why you minus it from the max length? So that it not go beyond the list. Okay, just like sliding approach. Okay, so you have if I have on text, so it's better you can go to the mirror. It will be the better for me for understanding purpose. So let's say I have one text. Let's say I have one list. Let's say one. Okay, I need to select the pen. Let's say 1, 2, 3, 4, 5, 6, 7. Let's say 8. Okay, and let's say 9. So I having a context size of 2. So first it will go from here, then it will go like that, it will go like that, it will go like that. So after that you can see just getting as a 2, getting as one value. Okay, but our in our case our context size is nothing but the 2, or you can say our sliding window is nothing but the 2. The value of the sliding is 2. So in here it will give me some kind of index error. Okay, obviously it give me some kind of index error. Simple path, by simple path. That's why we just minus it from here. Okay, we just minus it from here so that we don't get any kind of errors. Now we're passing here the stride itself. So let's say stride. Okay, now we're simply going to give it here. So why a stride? Because based on the stride, you're going to creating here the data sets. If we give it here one stride, it will move the input to for the positions to the one. Okay. So now we're to creating here two variable for input chunks. It's called the chunk, and we're simply going to take it from the token IDs. So let's say token IDs. So we can go from I to it's I to I plus the max length. Okay, it will go to the max length. If I had the max length of the force, so high and our it start from 0. That's means 0 to 4. Okay, high and I value is 0, so you can say 0 to 0 plus max length. So max length is 4. That means 0 to 4. So first 4 token is considering as an input chunk. Okay, now what about the target? So let's say target chunk. So target chunk is same thing from the token IDs. So let's say token IDs, and it will start from I. Okay, I to same thing. See, I to so not I actually I plus one, because we give it to here for the one position move. So one plus, then you can start from one I plus max length plus one. Okay, see, one to max length plus one to max length plus one, that you can see on here. Maybe here you go actually. Here you can see. Oh, it's not showing up. Okay, that you can see. So high end, your input is nothing but one, then you can see output. So same thing on here, you can see high end token ID is nothing but the one. Okay, token ID is 0, sorry, token ID is 0. So your target chunk is nothing but from 1 to max length, 1 to max length. Okay, that you see on here, 1 to max length. You can see 1 to max length. You can see 1 from 1 to max length plus 1, that you can see. So if it is a content full of the length, so high and the iteration is 0. So this is our input chunk that you already created. So y should be the plus 1, and here also plus 1. I mean the max length plus 1. Okay, same thing you actually implement it on here, that you can see on here. Here you can see. Okay, now we're simply going to store it. Okay, so let's say self dot, so that we created input IDs dot, you can using the append because this is in list itself. Okay, so append, and you're going to convert them into tors.tensor. Tors.tensor to convert them into the tensor so that you can also do some kind of operations. So let's give it to here the input chunk, and then we have the self dot target IDs dot append, and you can give it to here tors.tensor, and you can give it to here the target chunk. Okay, target chunk. So in our data, I mean dataset class, so we have two property. One is called the length, and another one is for the get item. So using length, it will just return the total number of row in the datasets, and using this get item, it basically return a single row from the datasets. Okay, so that you can use it as a batch size. Okay, so what you can do, you can simply going to say that let's say def, then underscore length, and then you're simply going to give it to here the self, and then you can return here the length of the self comma the input IDs. Okay, self dot input IDs. Okay, input chunk or input IDs, it should be the input IDs. Okay, that's it. And then it also give it to here another one. It's a def, that's a get item. So how are you actually calling here this GPT dataset version number 1? So it will automatically call it. So we need to give it to the IDX, and then you're simply going to return here the self dot input IDs, and you're passing here this IDX, and then as well as we're going to return here self dot the target IDs, and you can also give it the IDX. Okay, that's it. So that's our GPT data class. Okay, now what I can do is simply going to actually creating here and data loader. So in our GPT-2 version number one is a class is based on Python dataset class. So it's defined how actually individual row are fetched from the datasets. So here each row consists a number of token ID, that you can see token ID based on the maximum length assigned to the input chunk, that you can see assigned to the input chunks as well as the target chunks. Okay. Now we need to creating here and data loader to generating the batch of input with PR. So if you have the knowledge of the deep learning, you know that what is a batch actually. When you are going to putting something to our neural network or putting the data to our neural network, we have to put it in terms of batch size. Okay, that's why actually creating here this GPT dataset version number one. Now we need to creating here at data loaders. So let's creating here a class, sorry, functions called create data loader and make it version number one, and then you give it your text and the base size. Let's say base size, let's make it just give it some default base size, let's say 4, and max length, let's give it to here 256. I just give it to here as a default parameter. We can change this later on when you give it to the below the parameters below. Then we give it to here a stride as, let's say, 128, quite big number, and let's make in the shuffle is equal to true, so that you can shuffle the data. So we can make the drop last, drop last is equal to true as well, and then we're simply going to give it a number of workers. Okay, number of workers. So number of workers means it's nothing but the question is from the operating systems. Okay, if you have the, it's nothing but kind of threading operations. If you have the multiple number of GPUs, you can do it here, how many worker you have. Okay, it's just nothing but threading operations. So now we're simply going to using here this tick token. So let's say tick token dot get encoding. So let's say get encoding, and then you can give it to here the GPT-2 that you already created. So this is my tokenizer. Let's say tokenizer. I'm just getting here at tokenizers, and after that I am going to calling here my GPT datasets that I created, and here I am going to pass in here the text, that tokenizer, and the max length. Okay, the max length and the stride. Okay, so when you give it your default parameter, you don't need to pass it to your parameter if it's not needed. So let's make it as a data set. That's what data set actually. So after that, what I can do is simply go to creating here add data loaders. Okay, using here is pythons. Okay, data loader that you already inputted plus, and inside that you're going to give it to here the data set, and then the base size is nothing but the base size itself, and then we have the shuffle. So same thing, shuffle is coming from the parameters, so make it shuffle, and the drop last, same thing, drop last. I just give it to the same variable name, and number of workers, how many worker you have. In case of the threading, I just have the one, not one, actually zero. And then we simply going to create it here one kind of variables called data loader. Okay, let's say data loader, let's say data loader. So what is the drop last actually? So drop last is to drop the last batch if it is shorter than the specific batch size to prevent loss spike during training. Same thing as the context size that we discussed in the case of max length. When you don't get any kind of actual batch size, when it is go beyond the sequence, so it will just going to drop the last value from here. So the number of workers is nothing but the number of CPU process to use the processing actually. I mean, how many CPU you have actually. So I just make it as 0. So then we're simply going to returning here the data loader. So let's return here the data loader. Okay, so I mean, I load it. Now we're simply going to loading here our data sets. So you can copy this out, and after that what I can do is simply going to calling this one, I mean the create data loader. So create data loader be version number one, and you can give it to here the raw text, and our the batch size, let's give it a batch size, let's give it here one just for the demonstration purpose, and maximum length is nothing but 4, that you see in the example cases. And the stride, give it to here 1. I mean, same as the book that you can see, same as the book, stride as a 1 that you can see, and give it here the max length, or you can say context size as a 4. Okay, and in making shuffle as a false, we don't need to shuffling our data sets. So let's say shuffle as a false. Okay, but how you actually creating his attention mechanisms as well as the training the GPT model, I mean, we're creating our chat GPT. So we're simply going to give it a shuffle as a true because it was shuffling with the data sets. Okay, now let's give it to here the data loader. Let's say data loader, I mean, creating here a variables, and then we can easily using here these iterations, I mean, we can convert the data loader into a Python iterator to fetch the next entry via Python built-in next functions, because we already implementing here the get item. So our get item actually return the total number of return a single row from the data set. So we can using here the iters and the next keyword, so in order to actually getting the data iterations and the fast batch actuals. So first you're going to iterate the data. So let's say you're going to using this iter, and you can simply going to passing the data loader, and we can also using the next method in order to get in the first batch of the data. So let's give it here data iters, and then we can simply going to give it to here the first batch. So let's say first batch. So using next of the function, you can get in the first row of the data, I mean data loader. So now we can simply go into printing the first batch. Okay, let's say first batch. अरे भाई batch. So आजा 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 थोड़ा time लगेगा. Any problems? So list indices must be integer or slices, not and tuple. So anything wrong? Maybe this is coming from the input chunk or token IDs. This might be coming from the token IDs. Okay, I need to give it to here the, I just give it to the comma. That's my bad actually. Okay, any error right now again? So data loader is not defined. So create data loader, uh, create data loader B1. Say data loader is not okay. Data loader, just make it. Okay, let's make it data loader. Okay, now I already got the answers that you can see. So our tensor is nothing but the 40367 2885 1464, and our next tensor is 367 2885 1464 and 1807. That's been our first basis working very fine. Now we can also checking our the next, I mean our next batch as well. So you can using this next key again, and we just make it as a second batch. So that's a second batch. So we can printing this out. Let's printing here second batch. Okay, that you can see the second batch 367 285 1464 1807, and 2885 start from the one because start give it as a one. That's why. So that you can see how we can actually compare the first and second batches. We can see that the second batch tokens IDs are shifted by the one positions. You can see one positions. So for example, the second ID is the first batch of the input of the 367. It is 367. So which is the first ID of the second batch input. So the start setting is detected the number of positions in the input shift across the batch, and immediately here are sliding into. So you can see sliding into. So it is start from 2885 in the case of target pair. Okay. Now what we can do, we can simply going to apply it to the 4. Okay, I mean the 4 stride. So we can copy this, and we can go to pass it to here, and we can give it your base size as 8 this time, and max length 4, and a stride is a 4. Okay, now let's see the input and targets. So in this cases, so we may get here two things. One is the input, another one is the target. You can just stack it from here because it's just giving here two values. You can see tensor 1 and tensor 2 with having the comma. So that's our input. So that's our inputs and the targets. Uh, we can extract it. So you can simply gonna printing it out. So what you can do, you can first printing the input. Oh, input. So we can simply going to show it. So you can give it here comma, let's say input, and then you can printing the target. Okay, let's say target. So let's say you have the comma, let's say targets. So you can also keep it here some kind of backslash n, so that after the next slide it will coming up. Same thing for the targets, let's say backslash n, and also the backslash n on here. Okay, now let's see that you can see how our input tensor look like. Okay, and this is my batch 403672851 same thing, you see you start from 367. So when the batch size is 1807, I mean, sorry, data is, so the next iteration should be start from 3619. Okay, so this is how we actually implementing here this data sampling with sliding. Quite tough, I know, but you need to learn that. Okay, so in the next one, we're simply going to implementing here the token embeddings. So see how you actually increase the state of 4 to utilize the data set fully. So we don't skip a single word actually. So this is avoid an overlap between the batches, since more overlap could be lead to the increased overfitting as well, because you can see some kind of overlapping problem that you can see. So in here you can see some of the word is coming again and again. So you can see the 367 is on here, sorry, 2885 is on here, same thing, you can see 2885. Okay, so in the next batch actually, I mean the next batch, you can see the value is repeating. Okay, that's when it seems to some kind of overlap problem or the overfitting problem, but that's not a problem actually. You also try to solving those kind of problem in the next any implementing to batters. So in the next one we actually implementing here that token embeddings. So that's it for today. Now hope you enjoy this full tutorial, and make sure to subscribe our channels and share with your friends, and we will back to the next tutorial soon.